So hey everyone, good day. We're back again with another Prism Caribbean video, and today we'll be trying to wrap up statistics. Of course, I'll be trying to do a major past paper question on statistics itself, so that we may be able to cover the topic in all its ways it may come. Because the past paper generally they tend to bring back the same format of question with regards to statistics. So today we'll be going through mode, mean, median in that respective order. And maybe things may change up, right? So let's start with mode. Now mode is really and truly the event which occurs most often, right? It's really the event which occurs most often. So let's say we have a table, right? Sorry for my really bad drawing, but it can work for now, right? Right? Let me just add another column there. Let's say this is green, red, blue, black, and purple. Right? Now let's say each one has a respective color by its name, as in maybe marble. Let's say marble color and number of marbles. Right, we're gonna go through with that numerical order. So let's say we have 7 red, 14 blue, 8 black, and let's just say 9 purple, right? We want to find the mode. Of course, the mode is the one which occurs the most often. Number of marbles, 14. You can see that that's the most out of all of them. So this will be the mode, right? So therefore, mode of marbles is equal to blue, right? Blue. And yeah, that's it pretty much for that. Mode is a very, very simple concept, of course, in math, right? It doesn't really get more harder than that. Now, mode and median, on the other hand, they tend to be a bit tricky sometimes, right? Of course, I don't really have access to graphing, but I can show you the concepts, right? But let's go with mean for now, right? So mean is basically the average, right, for a set of data, right? Oh boy, I spelled that totally wrong. Right, so let me just fix that there and we can move on. Right, so it's basically the average for a set of data. Alright, and sometimes you may see it as a symbol like this. When you see the symbol, don't be afraid. This symbol here means basically mean. When they say find this, it means find the mean, find the average for the set of data. Right, and this symbol also has a formula. Right, so when you see this symbol, you must automatically think about the formula which follows it. Right? Now, this might look strange at first, but when I explain it, you realize it's nothing hard. So it's just supposed to be a letter N, right? So this on top here, which of course we know they are equal, so they mean the same thing, right? This on top here, right, the numerator means the sum of all the values of observation. Sum of all the values of the observation. Right? This here is basically the total number of observations, right? Total number of observations or total frequencies. Of course, this this formula is quite important to note. Well, at least you can learn that this here is the mean, and you can just summarize it to say the mean is equal to this red circle here, right? Which is numerator, which is the sum of all the values of the observation, and denominator is the total number of observations made, right? So I'm going to show you all an example with this just now, maybe a bit more harder example, you know, because it's really not that hard of a concept, right? We must also be thinking about another formula, right, where we calculate the mean, right, from a frequency distribution right, with ungrouped data, right? So when we think of mean, we need to think about the first formula as well as formula 2.2, which is calculating when. So this is obviously not the name of the formula, but this is when it will be needed, or I should say when it will be used. And it will be used when we have to calculate the mean from a frequency distribution with ungrouped data. So the formula will be the summation of fx all over efx, which is just simply efx over n, right? So in this case, what the efx simply means, it is basically the sum of the frequency by the values from the observation, right? So I'm going to show this now in a example, so that you don't get tied up at all with this, because it's a very, very simple topic. So I'm going to keep that right there. And let's say we have the example on the side here. Let's say, for example, we have Mark, not the name of a person, but an actual Mark, right? Or score in an exam, or whatever you want to call it. Then we have frequency. Then we have E of F, which is basically the mark by the frequency. Let's say we have marks from 0 to 5 here. And then we have frequency for each one. 2 persons got 0, 5 persons got 1 mark, 8 persons got 2, 17 people got 3 marks, 23 people, let's say, got 4, and let's say no one got total, right? And so the summation of the frequency is basically the mark by the frequency. So 0 by 2 is 0, 1 by 5 is 5, 2 by 8 is 16, 17 by 3 is 51, yep, 51, 4 by 23 is 92, and then we have 5 by 0 is 0. And what we do now is that we add the total summation of the frequency to get a total, right? So this will be 92 plus 51 plus 16 plus 5, which we will get 164. But the question is, let's say they say calculate the mean of the marks, right? So we know now that the x bar, we know from the general formula that, yeah, that's how it's supposed to be, right? So we know from the general formula it will be EF of x over n. So we know the EFX is 164, and we know the n. The n is simply the number of marks. It will be 1, 2, 3, 4, 5, 6 marks. Remember, 0 is a mark as well. We have 2 persons who scored 0 marks. 5 persons with 1, 8 with 2 marks, 17 with 3, 23 with 4 marks, and 0 persons obtaining total. So that's 1, 2, 3, 4, 5, 6. And that simple calculation will give us the average to be 27.3. That's the mean, right? So, yeah. So that's it pretty much with that. I will be going over a past paper question with this, so no need to worry at this point in time. It's just basically to grasp the general concept. Right, so the next topic we will be going on to will be the median. So the median is basically defined as the middle value in a set of ascending or descending observations, right? So let's say we are given some heights, right? Heights as 169. Let's say all of these are in centimeters, just for the time being, right? We have 169 centimeter, we have 158, we have 173, we have 176 centimeters, 199, and we have a pretty tall person at 220 centimeter, right? Now let's say we want to have this in ascending order. The ascending order in this case will be 158, right? Then we have 169, 173, 176, 199, and 220. Right, that's 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, right? So what we basically do to find the middle term, we start eliminating. We take out the first, we take out the last, take out the second to last, and we take out the second to last. Well, the second and the second to last value. Now we realize we have two values. In a case like this, we need to find the middle of this value, the median, I guess in this case, you can see. So it will be 173 plus 176 divided by 2. So we take the both values and we divide it by 2. Note, a lot of times you will be only getting one value, but because we have an even number of values, we will be getting two values. So in this case, we add both values, 173 and 176, and we would be able to get 349 divided by 2, which will give us 174.5, right? And that's it for the median. No, median doesn't come as easy as this. This may come in a multiple choice like this. However, for the median, they usually test it with graphs, right? What you can do is that you can take the general concept from this and apply it to the graph itself, right? And you should be able to get your answer, right? So, things to note, right? So now we'll be going on to things like ranges, semi-interquartile range, interquartile range, and I will just give you all the formula for probability one time, since that is quite important, right? So the range. So the range is basically the largest observation minus the smallest observation. That's simply the range. And then the interquartile range, which is sometimes given as IQR, interquartile range. This range, on the other hand, is so basically the quartile range divides an orderly set into 4 parts. So the quartile range divides an orderly set into 4 parts, right? So Q1, which is the lower quartile, right, is the value below which 1/4 of the data lies, right? The middle quartile, which in this case is Q2, is the value, right, value below 1/2, sorry, which should, just for English purposes, below which 1/2 of the data lies. And the upper quartile, which in this case is Q3 of course, is the value below which 3/4 of the data lies, right? And as I said before, the interquartile range is the I didn't see it here. The interquartile range, which is given as IQR, right? This is the difference between the upper and lower quartiles, right? Which will, in this case, would be Q3 minus Q1. So the interquartile range will be Q3 minus Q1, which we have here, Q3 and Q1, right? And the semi-interquartile range, which is given as semi-interquartile range, is basically the interquartile range divided by 2, right? Divided by 2, okay. Divided by 2, which is basically equal to Q3 minus Q1 divided by 2. And really and truly, it's that simple. Of course, I know I haven't showed any example with it here, but I'd rather save it for the past paper questions where I can get it onto directly, and I don't want to make the video too long, right? I just want to get straight to the point. So again, the range is the largest observation minus the smallest observation, and the interquartile range is the difference between the upper and lower quartiles, right, which is Q3 minus Q1, where we know Q3 is the value below which 3/4 of the data lie, and the Q1 is the value below which 1/4 of the data lies. Of course, you know the quartile range divides an orderly set into 4 parts, and don't forget the middle quartile, which is the value below which 1/2 of the data lies. Again, the interquartile range, we have Q3 minus Q1, and the semi-interquartile range, right, divides the interquartile range into 2, which basically means, in mathematical terms, Q3 minus Q1 divided by 2 is equal to semi-interquartile range. And that's it for that. I just want to show one more concept, which is basically the formula for probability, right? The formula for probability, right? Usually what I've been seeing in the past, because the trend lately, well, the trend a lot of times actually, was that probability was tested more with graphing questions. Like they would want you to look at a graph and understand what is going on and determine from the graph using a formula, of course, what is the probability. So the probability is really a measure of how likely an event will occur, right? So the probability of an event occurring is basically the number of favorable outcomes divided by the total number of possible outcomes. And that's it pretty much. So you take the favorable outcomes and you divide it by the total number of outcomes that is possible, right? I will try to show this in a question to come, maybe through a past paper, hopefully. So the favorable outcomes will be the number of outcomes that may have occurred, and the total number of possible outcomes is just simply the total number of outcomes. So the probability will be you taking the first part, which is what I said with number of outcomes which have occurred, and then you're dividing it by the total number of possible outcomes, and you will get it as a fraction, which you can then put it into a decimal form, or probability can also be placed in a percentage form. And that's all you need to know about probability. And this is just the gist of it for the statistics section of the CSEC math syllabus. It's a very, very simple topic, often confused because a lot of students may not have gotten the best grasp, or they may not have picked up the grasp of it. And the next time you see a video with probability is when we do a past paper question on probability itself, right? But for now, this is Prism Caribbean statistics, and we'll be moving on to the next topic for the next video to come. I am your tutor, Jordan Jaffa, and this has been a wonderful session. Thank you very much, and I'll see you in the next video. Take care.